All right, let's go ahead and get started. Hi, everybody. How are you all doing today? Everybody get their program in? How many of you thought that was kind of fun? Programming is kind of fun, right? Like when you're done, it's not like you don't know whether your program works or not. You know. You should know. Maybe you missed something, but you probably know whether your program works pretty well or not. And it's kind of fun creating something and building something, right? And bending the computer to your will. Do you feel that the computer had to submit to what you were doing? All right, it's a feeling of power will come later. This is kind of like, C-spot run of computer programming. But it's a first step, and it's an important first step. So let's go ahead and see what we talked about in the past. All right, last time we talked about an algorithm. What's an algorithm? A series of ordered steps used to perform some task. Right. And we have a program that's next. What's a program? Yes, algorithm executed, computer. Yes, something like that works. So this is important. Everybody kind of feel that they understand this now that they've come up with an algorithm and written the program to get the computer to do it. How many of y'all kind of feel that makes sense? Awesome. All right, last time we talked about some additional data types. We finished up talking about those. These were bigger data types like long and unsigned, and I showed you kind of the difference between signed and unsigned. We talked about how to do output very briefly with cout. That was pretty easy, right? Cout, kind of straightforward. We talked about how to do input using cin, and what did we learn about cin? Two important things. Sir? cin tries very hard to figure out the input based on the variable type that it is trying to read data into, right? It will try very hard to do that for you. And what else do we know about cin? Yes. cin is a quitter. cin will quit the moment it gets a type error. And when we say quit, how long does it quit? For the rest of that entire run of the program. It will any other cin statement that you encounter will be skipped, essentially. So no other input will happen. All right. So if it quits for all, it quits forever, we answered that. Oh, wait a minute. It's time for our brand new exciting game show. The very best game show in computer science in all of Georgetown University and possibly most of ICC. It's called The Code is Right. Everybody, yay! All right, it's time for The Code is Right. What I'm going to do is I'm going to give you this program right up here. You can take a moment to read it. And what's going to happen is when I change the slide, the input will appear on this side. And it is your competition to figure out who can give me the correct output fastest. Okay? Do everybody understand what's happening? We have this program, pound include iostream using namespace standard int main, x equals 19, cin into x, cout x, return 0. Pretty simple algorithm, input and output. Everybody see what's happening here? Now, I'm going to need help from the audience here, because what I'm going to do is once I flip the side and the input appears, I'm going to watch them. And the first one to raise their hand gets to answer the question. Once I see someone's hand going up, the slide will flip, and there will be you won't be able to see what's there. You'll just have to tell me the answer. So make sure you know the answer before you raise your hand. All right? Everybody understand the instructions? Are there any questions? Questions from the audience? Yes, sir. Yes. I missed a semicolon, didn't I? Oh. All right. That's what I get for just typing it up in my office for a second. So, all right. Is that better? Yes. So I didn't get a chance to actually copy this over because it's pretty simple. Are we happy now? All right. Here we are. Everybody ready? Are you ready? All right. When I hit the space bar, the next input will appear. The first one to raise their hand gets to answer the question. On your marks, get set, go. Who was it? Answer 12. That's correct. Yay. Okay, we're not done yet. We have another couple of rounds. All right. Get some more input here. On our mark, get set, go. I think it was Dylan. 73. Let's see if that was correct. 73. Let's go back and look why. Here we are. We're inputting things into an int, but we have a decimal. What does cin try to do? It takes the longest thing it can, which is, Dylan? Right, it says, what's the longest int I can make out of this? 73. Then I have a dot, so I will stop there. So the answer is 73. Everybody good with that? All right, one more exciting round. On your mark, get set, go. Oh, Scott, what was it? 19. Yes, sir. There you go. Why is it 19? You expected me to throw one of these up there, didn't you? Yeah, so the first thing that happens is it reads the dot. Is the dot an integer? No, the dot is not an integer. So what happens is it quits. It outputs whatever is already in there, which is 19. All right, Scott, you won our grand prize, a berry lemonade kashi bar. And I have some consolation prizes for everybody else. Thank you. Whoops. All right. Big round of applause for our competitors, please. Whoops. Yay. All right. All right, so that's one thing we looked at last time is we looked at CN and when CN breaks. And that's essentially what you need to know. It overwrites things. It gets the biggest piece it can get. And if you get a type error, it quits. When it quits, whatever is already in the variable will be there. It will not revert. It will essentially whatever's in the variable will be there. On occasion, CN will put in a 0 for you. They've changed that recently. But CN generally quits. Okay? Okay, then we talked about Boolean expressions. What is a Boolean expression? Something that returns either true or false. And we talked about all of these different signs. Help me out here. What's the top one? Equals, then. All right, so we had equals, not equals, less than or equal, greater than equal. We also had this exciting thing, which is, and what does bang mean? What does not do? Whatever follows it gets flipped. So if whatever follows it was true, it becomes false. If whatever follows it was false, it becomes true. We had this operator, which is, what does and mean? If both sides, if things on both sides of it are true, the whole thing will be true. If both things are not true, it will be false. So, if one thing is true and the other thing is true, the whole thing is true. Otherwise, it's false. Both things have to be true. Okay. We had this, which is or, and what's or? If either of them is true, both are true. It's only false if both of the things are false. Does that make sense? Everybody with me? Questions so far? Oh, it's time for another exciting round of our computer science game show. The code is right. Yay! We have a program. I left out some of the header stuff, and it goes like this. If condition, which is what we're going to be showing you, see out true, else see out false. The condition, the thing that you have to evaluate whether true is false, will appear in this other column titled condition. Does that make sense? And your job will be to raise your hand. First one to raise your hand gets the answer true or false. Winner gets a roll-up. Okay? Winner of the entire round gets another exciting berry lemonade kashi bar. And I have actually Snickers bars most of the time, but I ate the last one yesterday. So when I go to Costco this weekend, we'll upgrade the prizes later in the semester. Okay? Everybody excited? Contestants, are you ready? Here we go. Condition 0. Oh, I think, Michael, you were a little bit faster there. False. That is correct. False. Yay. Okay. Are we ready for the next round? You ready? Condition is P. Oh, Kelsey. P is P true? Why is P true? Anything that is not 0 is true. Here you go. And one final condition. Are you ready? I think you're going to catch up here. And our condition is, why is it false?
Oh, no, it's true because of the decimal.
Oh, I don't know. What do you think? Because it's the brackets. This makes it true. So, wait, who answered that right? Everybody answered it right. Okay. All right. And finally, I think we have one more round of this. That was true. We have one more round, and this is the challenge round. I think. I can't remember the order I did these in. Are you all ready? Here we go. Oh, wait. No, wait. That one's not the challenge round. Yes? Wait. You raised your hand. Was it false or true? Oh. All right. Next round. Are you ready? Yes. Oh, what was your answer? What was your answer? No, you can have it back here. All right. Yes, there was a bang around all of it. So the fast way to evaluate these, right, is you look and you see it's an or. So if either of these is true, then 1. So you just look at the first one, is 19 less than 20? Do you even need to look at this one? No, because 1 is true, but there's the tricky not snuck in the front of it. So, all right, who has the most Rolos? You're tied? All right, I get the Kashi bar, and you all get more Rolos. Here you go. All right, a round of applause to our contestants. Thank you, thank you. All right, so this is just a fun way for us to review things as we go along in class. How many of you all think this will be fun in the future? How many of you all would rather be set on fire than stand in front of the classroom? Okay, well, I'm going to take that as a we'll keep doing this. All right, so I think that's everything we covered in our class last time. All right, that was our fast review. Everybody good? So let's start talking about some new stuff. Well, first let me ask, any questions come up during the during your code writing that you need answered really fast? Questions? Sir? No, float or double is fine for this assignment. In general, I think in the future, I would use a double. There's a trade-off between how much accuracy, floating point accuracy you get, and how much memory you take up. In general, double is a good balance between the two. Yes. No, you just use the word double, just like you would use float. And once you use double, everything works exactly the same as a float. When we do division, when we have the division sign, if either of the thing is a double, it will do double, essentially floating point division. But if they're both integers, it will do what kind of division? Integer, okay? Pardon? Unless you do a static cast. But double is a good trade-off. We normally just start with float because that's like the most basic one, and then work up from there. I don't know. Maybe I should just do double from the beginning. Okay. Other questions? All right. Well, let's talk about some new stuff. Our code this time, when we output stuff, we just output kind of regular, straightforward stuff, right? And we didn't do any fancy formatting. So what I want to talk about now is if you want to format the output of your code, how you're going to do that. So what we're going to do is we're going to write a little program here. Oh man, hang on one second here. I'm trying to keep the code nice and neat for you so I can upload it and then you can like go to any particular day and see the code we did that day. All right, here's our basic program. What does this do? Does pretty much nothing, but that's fine. All right, there we go. Now it's fine. All right, so what we're going to do is IOStream by itself gives us cout and cin that will let us do input and output. But in order to kind of separate out the functionality so you don't have like giant libraries, often functionality is split between multiple libraries. And it turns out that for this IOStream stuff, if you want to do formatting, there is another library you need to use, which is called iomanip. Man, how I botched that. iomanip. And what iomanip does is it allows us some other things that we can do for formatting. So, for example, let's just write something that does a little bit of output. And we'll say int integer equals, anybody's favorite integer out there? 33. We'll have float, and I'm using floats on purpose, even though doubles are better. And this will probably work out to show you why doubles are better. So we have some floating number, which is a real number, and we're going to give this 4.5. And then we'll have, how about a character? There. Char character, which is going to be anybody's favorite? We could make it 0. It just gets a little confusing. So I'm going to keep it. All right. So here we go. We have some integers, and now we have some stuff we want to output them. So let's see out them. Oops. All right, so all we're doing here is just outputting the things that we have, right? An integer, a real, a character, and an inline. And what do we expect to happen here when we do this? Sir? Okay, so we expect to have all these things print out just like we did, and 6. And so we'll compile this. Compiled cleanly. So we'll run it and see what happens. Any predictions? What's going to output? They are probably all going to be jammed together, aren't they? And the reason they're going to be jammed together is we didn't put any spaces in between by hand. And you all did that for your program, right? Probably put some spaces in. Which is one way to do it, right? Instead of being spaced out the way we like, they all end up get jammed together. So one thing we could do is we could go in and put spaces in by hand. But there's a better way. And the better way is this. There is, hang on, I'm going to make the font a little bit smaller so I can get things on one line. Is that too small for you all to read, or you can read that? Okay. So there's a better way to do things. And what we can do is we can put something in called SETW, which stands for set width. And what set width will do is it will say, for the very next thing that comes along, that is, the next thing is integer, how many spaces to use to print that integer. Does that make sense? How many spaces to use to print the integer? So let's say that we tell it to put 5 spaces to print the integer. What it's going to do is it's going to take 5 spaces and put the integer in those spaces. So I'm going to leave the other line there, the line we had before that jammed everything together, so we can see the difference between the two. All right? So I will recompile. Compiled cleanly. That makes us happy. And when we run it, something happened. What happened here? Yeah. Yeah, it put 5 spaces. So our number, what was our integer? It was 33. 1, 2, 3, 4, 5. And if I highlight those spaces, we can see that there are 5 spaces that were used to print that integer. 2 spaces were the numbers, 3 and 3, and the 3 spaces ahead of that. Now notice, what did set width not affect? Anything else, right? So when you use set width, it only affects the one thing right before it. So let's add a couple of more set widths in another line. So we'll have set width int 5 integer, we'll have set width 5 real, and then down here we'll do set width 5 the character. So now what we've done is we've said every time you print something, make it 5 characters. 5 characters wide, or essentially 5 columns. Everybody with me on this? Sir? There is a real term for it, and I don't remember what it was. So it's a it's like a stream manipulation operator, I think is probably the real name for it. Yeah, I would just go with stream manipulation operator. It's not in my name. There's probably a real name for it in the book, and the honest answer is I don't know. I just use it without worrying about its name. Kind of like that thing that holds liquid, you know, that you can drink out of. What is that? Yeah, a cup. I don't really worry about that name. I just use it without. Any case, so it's easy to use. So I think it's a stream manipulation operator, or stream manipulation. It might function or method. So, all right. So what are we going to have happen here now? for this third line of output? Any predictions? Things going to be spaced out a little bit better? Let's try it and see. Compiles cleanly, that we're happy. And we run it, and now we can see that each one of these things was formatted into 5 spaces. And we can count them, right? I can highlight 1, 2, 3, 4, 5. I can highlight, whoops, for the 4.5, 1, 2, 3, 4, 5. Right? So the decimal space counted. And for the A, we did 1, 2, 3, 4, 5. So when you're formatting output, you can make your output very neat by using this set width, and things will appear in columns. It's useful for numbers and tables and things like that. Okay? Questions? Yes, sir. Okay. So the question naturally arises, which we always have happen, which is what happens if, let's make that a little bit longer. Let's make our real a little bit longer. Did you see what I did? I added a couple of digits. And what we'll do is we'll compile it. It compiles cleanly, thank goodness. And you can see what happened is here it was all jammed together. Here it was all jammed together. And here it ended up being all jammed together again. Why is that? Because we told it to print using five spaces, 1, 2, 3, 4, 5, and it used up all of them. So there's no space. We would have to make it. Right? Now the question then becomes, what happens if we told it to print in 5 spaces, and we have a number that is actually more than 5 spaces? Anybody want to guess what happens? What? So we have somebody suggest that it might truncate. What else might it do? Round? Did somebody say round? So it might truncate, it might round. What else? In theory, it might overwrite the A. That would be bad, though, right? Because you don't want your output, like, it's bad to overwrite output because people might be expecting to see something and it's not there. Like, think about an aircraft, like a fancy aircraft display panel, right? You're like, rate of descent, and you have like all these decimals and it's overriding the collision or warning or something. So it's a possibility, but people would try hard to avoid that. Any other possibilities? Yeah. Ignore the set width. So we have truncate, round, overwrite, which I'm just in general, it's a possibility, one that I wouldn't have thought of because it would be a sin to do that, and then ignore it. So let's see which of these happens. We'll compile it, we will run it, and what happened? It ignored it. Yeah, we set it to print out in 5 spaces, but it used 7 because the thing it was printing didn't fit into 5 spaces. So set width, if you give something bigger, will essentially ignore it. Okay, one other thing quickly about set width is that we can also use like string literals, which are phrases. Right, something like that. And when we compile, it'll also put that. I told it to use 15 spaces, and so it ended up using 15 spaces for that. Okay. Everybody kind of see what's happening here? So set width tells how wide to put it. If it's too long, it'll just overrun. It'll ignore set width. It works on longer strings type things too. Straightforward? Everybody good? You have to use it every single time. That's part of the annoying part of it. You'll see eventually that you have to use it every single time. All right, so let's see what else. All right, so let's just take a minute. And what I'm going to do is I'm going to call this format2.cc so that we have a different one and you can compare the two. And what I'm going to do is I'm going to get rid of the characters and stuff. Let's just focus on what happens with floating point numbers, okay? So here's our floating point real. And we made it 4, 5, 6. How many people does it bother that the 6 is in the wrong order after the 7? Anyone? It bothers me, but I'm not going to change it because I don't want to admit it. Okay. So we have this long decimal number. And we want to output this decimal number. When we run this, what number do you all expect to see appear on the screen? This is a trick question. You expect it to print 4, 5, 6, 7, 5, 7, 6, 8, 9, 0, 1, 2, 3. right? Is that what you'll expect? How many people expect that? How many people are going to be disappointed if it doesn't happen? All right. Well, I hate to break your heart here. So let's compile this program, format 2.cc. All right, it compiled cleanly. Now we'll run it. 4, 5, 6, 8, 9. Is that what you expected? How many of y'all are disappointed now? So here's the deal. Here's the deal for how this works. By default, well, let's try one other thing first before we start talking about things. So we notice it didn't print out all the digits. It left some off, right? Well, let's try something else. Let's change the value of real and make it something else and then print it again. So here what we're going to do is we're going to set real equal to 44.576890123. And we'll print it again. What number do you all expect to see appear here when we try and print this? 44.576. Well, should we go back and look at what we had last time? All right. Last time we had 4.57689, and we just added a 4 in front for the second one. What's going to print the second time? Ah, so you think the 9's going to go away? What do you think? You think it just matters on the decimal side? So you expect it to be 44.57689. Is that what you'll expect? What do you expect? You think it'll be 6 numbers? 6 total digits. Okay, let's try it and see what happens. I already made the change, right? Yes, I did. So we'll compile it. I'll clear the screen, and we'll run it. And now what happened? Yes? Oh. Yeah, I'm lazy, and I've customized my computer so that I don't need the point slash. And if you're really interested, I can tell you how to do it for your computer too, but not right now. Okay. So, anyway, I normally do the dot slash just so I don't confuse you, but I forgot because I'm lazy. So, yeah, I have my computer is highly customized, and I'm only barely functional at best on one that doesn't have all my customizations. It's really annoying for me. So, all right. So the answer is you were correct, right? What happened when we printed numbers is it by default only shows 6 digits. 6 digits, right? Which means that if we keep increasing the number of digits in front, we will get fewer and fewer decimals. So I'll put a 5 in front of there, and we can test to make sure this is true again. And you can see yes. Now, the question is, in this case, it's been rounding. But I just want to warn you, in my experience, when it chooses to round and not round is a little bit unpredictable, right? These are pretty clear cases because we have like a 9 on the end and an 8, 9, but it doesn't always work exactly like you'd think. Sometimes it rounds, sometimes it seems to truncate, and I don't have a good way to tell you what those rules are. All right. Now, everybody good so far? Everybody see that when we're printing out numbers by default, we get 6 digits, all right, regardless of which side of the decimal point they're on. How many people are happy? How many people are unhappy? Why are you unhappy? It's a stupid way to do it. Absolutely, I completely agree. It's a dumb way to do it. It's the way it does it by default, but it's dumb. And so the point of me teaching this right now is to teach you the way that you want it to work. Probably. I haven't tried it with a long double. Let's try it and see. I think what happens is that for long double, it internally carries more precision, but when it displays it, I think it still displays it exactly the same. Yep. If you're doing calculations, the long double would be far more accurate. Far more accurate. But the display is the same. Okay. Does everybody get that? The amount of decimals that the computer is working with internally does not relate to what it displays on the screen. It just doesn't. All right, so how many of y'all think this sucks? How many of y'all would like it to work just like you expect numbers to work? Me too. So let me show you how to do that. So right now, the way it works is it just shows you 6 digits regardless of whatever you're doing. What you can do to change that is this. When you put this word fixed into cout, if you do cout angle fixed, that changes the way floating point numbers work. And it changes it permanently throughout the rest of the program. Okay? So now when we run it by adding the cout fixed just once at the beginning of our program, we are going to get something different. Oops, if I run it. Now you can see what's happened is now it's showing a fixed number of decimals. And the fixed number of decimals is 6 decimals. So before it would show us 6 digits. Now that we've put that cout fixed thing at the beginning, it shows us 6 decimals. Is that better? What? Who thinks it's better? Well, no, because the number we had was like super long, right? And so it's kind of, well, we can, so the question is 6 digits the right number of digits to show? And how many of y'all think it's the right number of digits to show? It depends on what you're doing is the answer, right? Sometimes it might be correct to show 6 digits. How about if we're working in dollars and cents? 2 digits, unless we're at a gas station where we need 3, right? So we can throw that extra little 9 in there. Never makes any difference, but okay. So the other question is, this still defaults. It still defaults to 6 places after the decimal. If we want to change how many decimal places are shown, we do this. Cout set precision. And then the number of decimal places that we want. So for example, if we're dealing with cash, for example, we might want 2 decimal places. We might want other decimal places as well. So let's compile that and make sure that I haven't introduced some horrible. Let me just run the old one again so we can see what it looks like. I will compile it and we will run the new one. And now you can see it is doing 2 decimal places. And it is rounding. Right? Everybody good with this? All right. And if you want to show more decimal places, like, whatever you want, you can just change the set precision. So I'll make it 12 just for fun, and we should get, did I mess it up? 1x2. All right. So now we'll compile and we run it. We get lots of decimals. Hey, wait a minute. Something strange happened here. Okay, so what was our original number that we put in there? 576890123. 576. What happened to 8901? What is all this stuff? Nope, sir. It is the floating point error. Now remember, I told you that our floating point numbers are the sum of a series of fractions. What happened in this case is that our data type, a float, couldn't have enough precision to accurately represent this. This is representation error in action. Remember we talked about representation error? This is representation error. Even though we told it to use a different number, 576890123, 5768, and here it got as close as it could. And what's kind of interesting is if you look for the others, they end up being a little bit different because it's using part of the space for the larger integer number, so the decimals aren't always the same. All right, do y'all see that? We get error in our lower decimal places because of the representation error in there. Does that make sense? Everybody see what's going on? Questions? Yeah, the code page. Yep. And this code will be posted online when I get around to doing it, like this afternoon, so you can just download it too. Yes? Yeah, so what happens is like this is what's called a token. It's a token you give to cout. And when when cout reads that token, it goes, oh, I have to change the way I operate. So what you can think about is like cout has some internal settings and little levers and stuff. And as it reads things, when it hits these keywords, it goes, oh, I have to change internally the things I'm doing. Does that make sense? So these are just like you're putting a little command in there, and then as it processes these commands, it changes the way it works. All right, so we have this problem now that we have these like weird decimal numbers. How could we fix this? Yes? Well, we could try changing our float to a double. Let's see if that helps. We'll compile. It compiles cleanly. We run it. And now 4, 5, 7, 6, 8, 9, 0, 1, 2, 3, 0, 0, 0. Right? Which means it's as accurate as we need it to be. So I changed the float to a double, and everything got better. Yes, sir? A double is a long float, essentially. I don't know if you can declare a long float. I think that might not be the right language for the compiler. But a double is essentially a long float. We can just try and see if long float works. Nobody write this down because I have no idea what's going to happen. Except I'm videoing it. Yeah, so long it doesn't really work. So it thinks you're trying to make an integer. Does that make sense? So yeah, so a double is essentially a long float. And in general, you should just use doubles, right? In general. The question might come up, when do you not want to use a double? And the answer is, if you program enough that you end up in a situation where you don't want to use a double, you'll know it. And by then you'll know enough to like figure out which one you want to use. But because I mean, essentially what's happening is each floating point number is taking up twice the memory. And your computer right now has so much memory that we in this class won't come close to using it all. So it won't be until you get into some sort of high performance math application that you'll have to worry about like trading off how much memory you have for what floating point representation to use, okay? So that's a ways away. So just right now use double. I typically just use double by default, and I've almost never run into problems. In fact, I'm not sure I've ever had to use a long double. I don't think I've ever had to use a long double because I don't do much math stuff. Okay. All right, how's everyone doing? Everybody see what we're doing here? We are changing our output format to make things better. So when you're doing floating point displays, this is what you can do. Questions on this? Going once? Going twice? Yes? Yeah. Sorry. It got messed up because of that weird error, but I can run it again if you want to see it. So. Is that all you needed? You can download and run all this code yourself. I'm going to post it up on Facebook or whatever. Yeah. Yes. Yeah. I believe set precision and set width are part of IOminute. Other questions? All right, so we'll move on to the next topic. But first, we're going to take a 1-minute break so you can stand up and stretch. You're all looking a little glassy-eyed. Even though I don't know why this is so exciting. Output formatting is so exciting. I can't understand why you're not just jumping with joy. Did you get that? Yes. No. It's for people who are paying attention. So they were paying attention and raised their hands when I held up the roll. Everybody else was like on your computers looking at your MySpace pages or something. So. All right. All right, welcome back. So one thing I want to show you pretty quickly, because it ends up being common. One of the things that we often do in computer science is we have some number, and at some point we do some stuff in our program. And what we want to do is we want to change the value of x. And often we change it by adding something to it or subtracting something to it. For example, if you're going through a bunch of stuff one at a time, you might have a counter that counts up every time you go through something in a loop. We haven't gotten to loops yet, but you should remember them from the flowchart. So often what we want to do is something like this, x equals x plus 1. And this is a super, super common operation. So because programmers are lazy, we don't like to type, and so we try and reduce the number of buttons we have to push on the keyboard, because that is how exceptionally lazy we are. We're willing to go to extra work to avoid having to do work. Right? So there are other ways to do this. So x equals x plus 1 means take the value that's in x. It goes off to memory, it gets this value, it adds 1 to it, and what does it do with it when it's done? Puts it back in x. Okay? So this statement says find the value that's in x, add 1 to it, put the resulting sum back in the x. So when we're done, the box that had x had a value of 5, then it has a value of 6. Well, this does exactly the same thing. X plus equals is just a shorthand notation for this, equals x plus 1. But we have to type 2 characters less, which on a like 7-character thing is like a 28% improvement, right? Maybe less than that. All right. Yay, lazy. Okay, so this works for everything. We can also do something like x minus equals 1 if we want to subtract. We can do x times equals 3 if we want to multiply. We can do x divided equals 7 if we want to divide. And each one of these things finds the value of x, does this operation times 3 minus 1, whatever, and puts it back in x. Everybody kind of see that? Do you want me to print out some of these? So often what's going to happen, we haven't gotten there yet, but often what happens is you use the same variable in multiple steps and do different operations on it at each step. And so do you want an example? I will show you an example, okay? Just because you asked, not because it's important, but so last semester, the assignment I gave to this class, the first assignment was like a heart attack risk score calculator. And I'm going to just pull up my solution to that, and I will show you exactly where I did this. This was a really long program because I was being a jerk to them, and I like you all better. But you can see, like, what's happening here is we go through, we have all these different things that you have to add together. So there's a total risk score that's made up of, like, a score based on your age, based on your total cholesterol, based on your gender, and stuff like that. And so at each step, you end up adding a little bit of stuff to it. This program is really long. It looks horrible, but it's actually very straightforward. It was just a lot of typing. Does that make sense? So here we have this thing where, let me see if I can find right. Here we have this thing where what we're doing is at each step we're checking what's going on and then adding something to this total score. Does that make sense? So we're using the same total score variable over and over and over again, but different things are getting added at different times. And we'll see more about the structure later. But does that kind of answer your question? I made it go away, but I can go back, yes? Yep.
So that's x divided, that's x divided by 7, right?
Yep.
So how would you do like 7 divided by
So let's just see out what happens here. I'm going to see out what happens at x at each step, okay? So the first step is we add what to x? And then what is the next step? This is the first step, and we add 1 to x, right? Everybody good with this one? What does this step do? Exactly the same thing. What does the next step do? What does this step do down here? Take whatever's in x and multiply it by 3. Does that make sense? And then the last one is take whatever's in x and divide it by 7. Now, what type is x? And what type is 7? So what type of division do you expect to happen here? Okay. So let's just compile that really fast and see if it works. It's 5. 5 is the initial value of x. I was just laughing because I accidentally, anyway, I didn't even know why. I'm just, because I'm insane, that's why. Okay, so we compile it. It compiles neatly and we run it. And we can see it was 5. We add 1 to it, it's 6. We add 1 to it, it's 7. We subtract 1, it's 6 again. We multiply by 3, we get 18. We divide by 7, and we get 2 because it's integer division, and we get 2 remainder 4. And we're not printing out the 4. Oh, we can do mod equal. We can also do mod if you want. Mod also works. So, but yeah, you can do mod instead. Now we should get 4. So, okay. So this is just a shortcut notation because programmers are lazy. Everybody good with shortcut notation? I just wanted to show it to you because it shows up often and you need to understand what it is. You can use it yourself. I use it in my code because I am absolutely lazy. All right. Let me just write this into another buffer, another program. We'll call inc.cc. And the other thing I want to show you is this operation of doing incrementing things by 1 or decrementing things by 1 is incredibly common. We haven't seen it yet, but incrementing things by 1 is so common, it happens all the time, that there's even a shorthand for this. And what it is this, plus plus x. And what this means is add 1 to x. Plus plus x. So if we see out x now, what do you expect this will be? Yep. So we'll compile that and see. Oops, wrong program. G++, I called it inc.cc. So you can look at that. And if we run it, I'll clear the screen, /inc, and you'll see it prints out 6. Because it took the initial 5 value, added 1 to it, and then printed it out. Okay. Everybody good with this? Yes? Because this is a special notation, a very special notation, because programmers are lazy, and now we've, instead of having to type 9 characters, only have to type 4, which is a 50% improvement in the amount of typing we have to do. This is a shorthand notation that the equals is just built in there. Does that make sense? Everybody good? Now, I want to show you something else, and here's where it gets a little bit wacky. The plus plus doesn't have to go in front, it can go after. It can be plus plus x or x plus plus. And the result, when we print it out this way, is going to be exactly the same. Okay? So, I changed the plus plus x to x plus plus. And the plus plus means increment it by 1. Everybody good? There's a slight difference I'll demonstrate shortly. What's the name of the language we're working in? What's it's based on? That's the joke right there. Computer science humor. It's a step up from C because it's C++, which is C. Okay. And this is why there's no computer science stand-ups on TV. So, now the weird thing about this x++ and this plus plus x is that they have slightly different meanings. And I'm going to show you those meanings right now. So here's what I'm going to do. I'm going to put this plus plus x inside the cout statement. X is 5. We have plus plus x. What do you expect this to print out? How many of y'all think it's going to be 6? How many of y'all think it'll be something else? What do you think it'll be? Think it'll be 5? Even though we put the plus plus? Okay. Let's take a look and see. we compile, and we run it, we get 6. Now you're not wrong yet. Because if we did it the other way, if we put the plus after, like that, now what would it print out? 5, because there's a little bit of a different meaning between the two. Now it prints out 5. When it's like, I'm gonna just put both on here so we can see them at the same time. When it's plus plus and then x means increment the variable, then use it. So in this case, it says plus plus x. I have to add 1 to x before I do the cout output. But in the next case, it says it's swapped. It means use the variable, then increment it. So x plus plus will say, aha, output whatever is an x, and then add 1 to it. So when we run this, what we'll see is we'll see that we get the same number twice. The first one uses it, increments it, and then outputs it. The next one outputs it and then increments it. And if we add one more cout x to the end here, we can see that when we're done, this line before still incremented it. I'm going really fast, so you all have to slow me down if I'm going too fast. Okay? So it outputs 6, 6, 7. Let's go back and see why. So we start with x equals 5. We call this line, and it goes, oh, plus plus x. I have to add 1 to x before I do the output. So it adds 1 to x, and x becomes, and then it outputs. Great. Gets down to this next line, and it says, okay, this time I have to use x and then increment it. So what is x that it uses? And so it outputs. And then when it's done, x becomes. And then finally down here at the end, it outputs 7, because that's what we got to. So again, this is a very common notation. Computer programmers writing in C++ use x plus plus and plus plus x quite a lot. All right. Everybody good with this? How many of y'all think you're good? Who's with me still? Who's against me? Such a complacent class. Okay, I want to show you a nightmare thing now. And what I'm going to show you is something like this. Now, in the old days, the compiler would let you do something like this. And what it would mean, it would be like, oh, find this variable, increment it before you use it, increment it before you use it, and then increment it and increment again when you're done. And in fact, you could have essentially as many of these plus pluses as you wanted, if you wanted. Nowadays, what's happened is the compiler writers have decided that this is horrible practice because it is cruel. It's painful to make people have to read code like this, so they don't let you do it anymore, which I am perfectly fine with. So I don't even think you can do one before and one after anymore. Oops. Yeah, you can't. So now you can only use one or the other, which is a shame because these used to make for really great exam problems. Because you put like 20 pluses in a row and people are like, ah! So now I have to write easier exam problems. Not really. Yes. Sometimes. Yeah, I mean you could download like the older version of G++ and use it if you wanted. So, and you know, upgrading compilers sometimes breaks old code because they used a notation or something that wasn't allowed. So, you know, we're talking about building code here. A lot of you know, people's job is not building new code, but just maintaining old code and kind of fixing bugs and working on it as it goes along. And a lot of programming is done to do that. Like at big companies and stuff, there's people whose job it is they just give you like a ton of old code, and they say, "Oh, we found the bug. Go fix it." And you're like, "Oh." So. All right. Questions on increment or decrement? Everybody good on that? All right. We only have one or the other. We can't do both anymore, sadly. Those were the days. It was uphill to school both ways in the snow, even in the summer. All right. Everybody good on this? All right. Let us do something else now. Now, one of the things that you have been interested in, and I've had a bunch of questions on, is how many of you all think characters are particularly useful? How many of you like characters? You're the only person. Everybody else hates characters? All right, I'm going to have a lot of assignments that deal with single characters now, just because I'm going to get you to like them. But by themselves, they're not particularly useful. When are they useful? In a string. We have a whole bunch of them. So just to get started on this, we have a library that lets us do things. It's called pound include string. And let me stop here for a minute and have an aside. All of you did your first program. How many of you all use Nano as your editor and G++? How many of you all bothered to figure out something else, like Xcode or something else? Which was better? So using the tools we gave you, Nano and G++, were kind of the simplest things that you could start with. And the reason I gave those to you first was because I didn't want to break your will to live by dumping like lots of stuff on you at once, any more than I am. So the tools, Nano and G++, are really simple. They're functional, they're great, but they're not as powerful as some of the other tools. As you go throughout the semester, you are welcome to keep using Nano and G++ if that's what you're happy with. I have absolutely no problem with that. But you're also welcome to switch to something else. You might switch to using a different editor on CS class. I would recommend Emacs, because Emacs is the editor I use, and it's not entirely dissimilar from Nano. It has a steep learning curve. You might choose something called VI, which is like the proto-cockroach editor that climbed out of the slime and never went away. And one of the great religious wars in computer science is Emacs versus VI. Everybody falls into one of two camps, and I'm hoping to indoctrinate you into my camp. So I recommend Emacs over VI. But you also might choose to use something on your own computer. If you have a Mac, you can open up a terminal window and do everything you do on CS class on your local Mac. Emacs is there, Nano is there, G++ is there, once you download and install Xcode from the App Store. Or you can actually use Xcode, which is like the full GUI and has a lot of stuff. It's very powerful. I'm not going to talk you through how to use it. If you want to come to my office hours or see one of the TAs, we can figure it out, but it's a bit more complicated. Yes? Yeah? Mm-hmm. Yeah, but you better read up a little about Emacs first. There's some links from the class webpage, because once you get into Emacs, unless you know the secret hidden control combination, you'll be unable to get out of it. So there's no quit, there's no menu, you just have to know the magic keystrokes. So it's a learning curve, but the difference is like Nano, like if Nano is a hatchet and you're going to cut down a tree with a hatchet, you can cut down a tree with a hatchet, right? Yeah, you can. Nano is like a hatchet, but Emacs is like a snowmobile engine mounted to a 6-foot chainsaw blade that can cut down a redwood in like half a second. Have you ever watched lumberjack competitions laid on at ESPN? They literally have these custom chainsaws where they have these like giant engines, and it's like who can cut the log the fastest. That is Emacs. The thing about Nano is you're not likely to hurt yourself. It'll be a lot of work. With Emacs, you can cut your own legs off before you even notice. Okay? So it's powerful, but with great power comes great danger. Okay? So, sir. Yep. I use both, depending on what I'm doing. So I use Aquamax for this because it's a separate window for you all to see. When I code myself, I use Aquamax. But if it's something small, I'll just run Emacs in the terminal. It just depends. I use both. Aquamax is just a Mac-specific Emacs. All right. So here's the deal, though. You're welcome to change tools. You can talk to the TAs about it. They'll be happy to help you transition. I will be happy to help you transition if you come to my office hours. But I need to tell you one important thing that started this entire rant, okay? And the one thing is that different compilers work differently. And even if it's the same compiler like G++, G++ on your Mac will work differently than G++ on CS Sun. And one of the places where people get into trouble is they stop using CS Sun. They start using their Mac, or for those of you who are PCs, like the equivalent on PC, there's other things you can use, Visual Studio, Code Block, something like that. And what ends up happening is then they turn in their assignment because it worked beautifully on their Mac, and they upload it on the Blackboard. And where do the TAs test it? On CS class. One of the differences between the Mac G++ and the CS Sun G++, CS class C++, is that on the Mac you do not have to put pound include string to get strings to work. And on CS class, I think you do. And so what will happen is students like yourself will write something on their Mac, they'll upload it, the TAs will go to test it on the CS class, and what will happen? The code will not compile. Did you look at the rubric for not having compiling code? Is it minus 40 or minus 60? It's big. It's a giant penalty. You want your code to compile, right? Even if your code doesn't work, you want it to compile. So one of the things that people get stuck on is they switch compilers, they do things on their Mac, they forget to pound include string on, the TAs download it and test it, and it doesn't compile, and everybody is sad. Except me, because my grading curve gets easier. Yes? They might. I think math.h works on everything, but sometimes you need to do the -lm. Did I show you that? And sometimes you don't. So, did I show you that? Apparently it works fine on CS class then. So, anyway, never mind. There's some legacy stuff just left over from the C days that are still around. All right. So there's my long spiel, meaning make sure you put the right headers in, and particularly if you end up using different compilers, make sure you test your code on CS class before you submit it. Got it? Where do we test our code? All right. Good. So we have pound include string, and now we can do cool things that make us happy, because instead of having to deal with characters all the time, we can put whole things together. So, for example, let's say we want to do some stuff, so we do string name. We use my name because I'm typing and I get to put my name in. We can do string something office. All right. We can do string, password. I'm never going to tell you my password, but all these things can go in together. What is the difference between a string and a character? You can use multiple characters, and the literals for a string use a double quote. If there is a single quote, it is a character. If it is a double quote, it is a string. This can lead to confusion, so this is perfectly legal. Oops, like that. So, you can have a string that is only a single letter, but it is a letter. Yes? Not today. There used to be. So you can use it's like Clippy. Hi. It looks like you're having a problem with the projector. I'm like, not for the last hour. Okay. So you can use double quotes and have a string that is only a single character. Okay? And it is different between the two. Yes, sir. Would letter and other letter be equal? Let me think about this for a second. We'll just compile it and make sure it works first. Okay. And we haven't output anything. Let me just show you one thing and then I'll answer your question. So once we've done this, we can use cout whatever we want. All right. What's going to happen when I print this? It's going to be all jammed together, which we don't really care about. All right. If I wanted, I could put some set widths in there, right? And make it big enough to print stuff. All right, we'll compile that and run it. And so set width, pretty good. I'm pretty good most of the time. I don't mess up too often. IOMANIP, thank you. Okay, now we'll compile it. That's much better, and we'll run it. And you can see it spaced out things nicely. All right, so the question is a string with a single letter and a character with a single letter equal to each other? And the answer is I honestly don't know, because the rules for for comparing things end up being a little bit complex sometimes in C. And what ends up happening is often things get cast from one type to another before they're converted. So I'm not actually sure what's going to happen here. We should take bets. This would be kind of fun. Anybody know the answer? I don't know the answer. Mostly because I would ever actually do this. And you don't have to do this. This is not testable material at all. I'm just doing this because every once in a while people ask questions that I want to know the answer to. So, all right. Who thinks these things are going to be the same? Uh-oh. All right, let's see. It's just not even letting us compare is the thing. So I'm going to do no, you can't do that. We could probably cast one. Yeah, I don't even want to get into that. So the answer is no, you can't compare a string and a character to see they're equal. Not without doing a bunch more work. All right, let's see. So we did some output, first name, stuff like that. All right, so let's talk about input. I'm going to make another copy of this. All right. Let's talk about this. Let's say that we want to do some input for somebody's name. Right. And we wanted to output it again. So, string name, cin into name, cout name. How's that look? Pretty straightforward? So before, this is a different version of the program. Before I had my name in quotes. It was an entire string little, including the space in the middle. Now, instead of, just seeing what the name is, we're going to ask someone for their name. What are we missing here? Yeah. So we'll ask them to enter their name, we'll enter their name, and we'll output their name. Everybody good with this? You're right, I need a semicolon. That's funny. All right, so we'll compile this. And we'll run it. So, how about my name? And what's this going to output when I hit enter? Oh, was that good? It's not what we expected to happen. Why did that happen? Because cin breaks on spaces. Remember, cin breaks output up on spaces. So when I used my name, I said Clay space Shields, which is the way I write it. And cin, because it's helpful, says, aha, you're trying to read a string. What is the longest string I can read? And what was the longest string that it could read? Clay. So it goes, okay, I read Clay, and then, stop it. It goes, okay, I'll read Clay, and that'll be what I output. So let's fix that. How do we fix this? Well, we can do two names. And we can do cin into first name, and then into last name, and it'll put it in both. And then we have to output the two. First name, and then last name. And we probably want a space between the two, don't we? So I'm just going to manually put a space in there because how long are people's last names? What? Maybe we don't know. We can't use set width. Everybody's last name isn't the same. Well, that's obviously an oversight. And in the future, everybody will be required to have 7-character last names. All right. So, all right. So this is going to work? Yeah? Okay. So here we go. We'll compile it and make sure it works. First name and last name, Clay Shields. Yay! And we're happy, right? Except, you know what? Clay Shields is what I go by, but it's not my full name. Well, that didn't work, did it? All right, how do we fix this? Middle initial? Okay, so we can do We could add an initial, but let me just save you, because if we had time, I would do that just to mess with you. There is a computer science professor. He is from, if I recall correctly, either Malaysia or Indonesia, somewhere in that region of the world, where people do not have multiple names. His name is Robbie. That is his full name, Robbie. And so when he writes his academic papers, it just says Robbie as the person who wrote it on there, because that is literally his full name. So what would happen here if we were trying to run our program for this professor? We'd enter Robbie, and it'd be like, okay, I'm waiting for your last name. You only gave me one. What's going to happen? Is he going to go out and get a last name, or he hasn't yet? It might be a long wait. Okay. So here's the problem. Do you see the problem is that when we're reading something, we sometimes, if it's a string and we know it's just a single sequence of characters without any spaces in between, we're good. We can use CN as long as we're sure whatever we're reading in is exactly one sequence of characters that has no spaces. Right? Does that make sense to everybody? The problem is, what happens if we're trying to read something that has spaces in it? Well, let me tell you what happens. What we have for that instead, I'm just trying to make a new copy of this file so you can copy it. So what we have for this is we have a special command that does input, and we mostly use it for reading strings, okay? And it's called getLine. And what getLine will do is getLine will read everything that's on the current line of text from where you're reading to the end all at once. So you say you're reading from CN, because that's the input, and you say you put what's in there in name. And what getLine will get is will get everything up to the end of the line where somebody hits return all at once, including spaces. Okay? So let me demonstrate this to you. We'll compile our new version of the program, which is strings 3. We will run it. And now we enter name, Clay Shields. And it outputs Clay Shields. We run it again. We run Thomas C. Shields. Thomas C. Shields. We run it again. We say Robbie. And it gets Robbie. Okay? So we have this other type of input called getLine that, unlike CN, does not break on spaces. Okay? And I'll show you some more stuff about getLine next class, and we'll learn more about strings.